Hi guys, I'm Yuki from External Development Japan at Solana Foundation. On most blockchains, we talk about whether your transaction gets in and how fast. But there is a third thing that moves just as much money, the order, where inside the block your transaction actually executes. Today, I'll walk you through Solana's ACE, Application Controlled Execution, with diagrams and animations. In one line. Right now, someone decides the order. ACE is about changing who that someone is. First, three things people conflict. Inclusion, does it get in and when? Ordering, where in the block? Finality, when it can't be undone. Speed upgrades like Double Zero and AlpenGrow mostly help the two ends. ACE touches only the middle, the order. Hold onto that one. And even after AlpenGrow, the slot time stays around 400 milliseconds. It's not a block every 150 milliseconds. Today, for each 400 millisecond slot, a single reader decides which transactions go in and in what order. One reader runs 4 slots in a row, about 1.6 seconds. The key point is, the protocol doesn't enforce the order inside a block. So, the right to decide the order is structurally up for grabs. And right now, the reader holds it. The roadmap notes that, as a byproduct of the scheduler's periodic auctions, takers tend to get effective priority over makers. So why does order become money? A maker posts an ask to sell at 100. Then the price jumped to 105. Now that 100 ask is still too cheap. An informed taker rushes in to buy it. The maker wants to cancel, but cancel versus buy. Which one runs first? That decides everything. In this time, the taker's buy runs first. The maker is -5, the taker is +5. That 5 moves straight from maker to taker. That's getting picked off. With ACE, the apps rule can process the maker's cancel first. Result is both flat 0. The loss is gone. And this isn't academic. The fewer of these picks off, the more confidently makers quote. The tighter the spread, and the lower everyone's trading cost. The goal is liquidity, not low volume. The heart of ACE, the app, not the block procedure, writes the ordering rules. Watch. The exact same bundle of transactions, but change the rule and the order changes, like this. And fee priority is today's baseline. On top of it, the app can branch. Process cancels first, and a small speed bump for takers. Collect orders and run a batch auction, or splice an Oracle upgrade to the front, JIT, just in time. That conditional logic lives in the app. There are 3 ways to deliver this, but they are not separate things. They differ only in where and who does the reordering along a transaction's journey. AMQ, the app, inside its own program. Available now, but you lose composability. And BAM, a trusted node in front of the leader inside a TEE. Already live ACE today, but you trust the TEE and operators are permission at first, JIT, and protocol ACE. The reader itself natively with multiple readers. The endgame, but a deep change, and MCL is contested and unbuilt. In fairness, BAM argues that if a node is compromised, you lose only that node's ordering and privacy, and attestation actually shrinks the trust surface. A single reader has a loophole: censorship. If the reader is the taker, they can simply drop the maker's cancel like this. That's why MCL, multiple concurrent readers. You broadcast the same cancel to readers A, B, and C at once. Even if A drops it, B and C include it, so the cancel still makes it in. And since it's the same transaction, it's deduplicated to 1 when the blocks merges. The point is, one honest reader is enough to defeat censorship. No single reader controls the outcome. To be straight about where this stands, usable today are AMQ and the lib BAM. Alpenglow is in testing, mainnet eyed for late 2026. Protocol native ACE plus MCL is a long-term goal still unbuilt, and MCL splits core developers. So ACE moves the light to decide ordering from validators toward apps, from today's BAM toward eventually protocol native ordering. That's the map. The plain world glossary and the sources are on the site. Link is in the description. Go play with it yourself. If this helped, subscribe, and I'll see you in the next one. Bye.